1 upon z square I will rewrite as, because here it is mod of z plus 1 is less than 1. Mod of z plus 1 is less than 1. So I will write this z as something 1 minus z plus 1, just an adjustment. Okay, because z plus 1 is less than 1. Z plus 1 is less than 1, it is given. So we can use any one of these four formula. Here if mod of z is equal to 1, mod of z is less than 1. So we have all these four series, okay, expansion. So out of that one I am going to use that one, because here z plus 1 is less than 1. So I will just write this z square as 1 minus z plus 1 the whole square. Okay, so there is no change in the value. You are adding and subtracting 1, and minus z the whole square will come, which is plus 1 upon z square will come. Okay, then this is equal to, we can write this as 1 minus z plus 1 the whole raised to minus 2. Okay, whole raised to minus 2, where this mod of z plus 1 is less than 1. This is less than 1. This term is less than 1. So you can use power series here. 1 minus z the whole raised to minus 2. Which formula here? See this one. Last one, fourth one. 1 minus z raised to minus 2. Okay, that formula you can use here. So I will write this as, this is equal to 1 plus 2z. 2z means 2 into z plus 1 plus 3z square. 3 into z plus 1 the whole square plus 4z cube. Z plus 1 the whole cube plus etc. From where? Using that series. Say I will give here it as, say it is understood actually. Say I am giving this as equation number 1 for your reference only. So from 1, using 1. Using equation number 1. Okay, equation name, that is not equation, it is power series expansion. Using that property we use this one. Now this is equal to, so it is done. Now the question is, you need to express this series like this. Okay, now this problem is already done, but you need to bring it into this form. So that is 1 plus, now look at that, look at the answer and look at here. 1 plus, now if you look at this one, this is 3, see, just see, here 3 is there. So 3, when it is 3 there, if I write there 3 factorial, or say 2 factorial and 2 plus 1 factorial. This 3 I am writing as 2 factorial and 2 plus 1 factorial. So what is that? It is 3 factorial by 2 factorial. Okay, 3 factorial means 3 into 2 into 1, by 2 factorial is 2 into 1. So to this cancel, you are getting 3 here. Okay, now this 4 I will write as 3 plus 1 factorial by 3 factorial. Okay, so this is equal to 3 plus 1 factorial means 4 factorial. 4 factorial by 3 factorial means this is 4 into 3 factorial numerator. So 3 factorial cancel and you are getting 4. Okay, so if like that, if I go on like this, if denominator is n factorial, then numerator should be n plus 1 factorial. Okay, here 2 factorial and 2 plus 1 factorial. Here what will come? Here in the numerator, 1 plus 1 factorial upon 1 factorial, first term, this term. So 1 plus 1 factorial means 2 factorial. 2 factorial upon 1 factorial is 2. Okay, so if you go on like that, denominator it is n factorial, then numerator will be n plus 1 factorial. Okay, so I will write here n plus 1 factorial upon n factorial. That is just to bring the answer into that form. And everywhere you can see z plus 1. The first term is z plus 1 raised to 1. Second is z plus 1 raised to 2. Third is z plus 1 raised to 3. Okay, so here it is n. And since it is sum of so many terms, we will write summation of n equal to 1 to infinity. Okay, that is just bringing the answer into that form. This is method 1. Now the method 2 for this one is the traditional method that you will find derivative of that and then simplify it. Okay, so I will show that too. So here method 2 is f of z is equal to 1 upon z square, and here mod of z plus 1 is less than 1. So that means here if I write this in z minus z0 form, it is z minus minus 1 less than 1. Okay, z minus minus 1 is z plus 1. So this is comparing with z minus z0. What is z0 here? Z0 is minus 1. Okay, z0 is minus 1. So f of z is this one. Therefore, f of z0 means f of minus 1. F of minus 1 will be how much? 1 upon minus 1 square. Minus 1 square. So it is plus 1. Then f dash of, means standard method you need to do. F dash z means derivative of this is minus 2 by z cube. Therefore, f dash of z0 means f dash of minus 1 equal to minus 2 divided by minus 1 the whole cube. So that it is plus 2. Okay, plus 2. We need the answer in terms of factorial. So, we can write this as 2 factorial. Okay. Now, f3 dash, f2 dash of z will be, derivative of this will be, we know it is 2 into 3, 6 by z raised to 4. Derivative of this denominator into derivative of numerator, or otherwise take this z raised to 3 to the numerator. So 2 into minus 2 into z raised to minus 3, then nx raised to n minus 1 formula you will use, and you will get the derivative here. Then f2 dash of minus 1, is equal to 6 upon minus 1 raised to 4, that is 6. 6 means 3 factorial. Okay, and so on. Then substitute the value. Same way f3 dash of z. f3 dash of z will be minus 24 upon z raised to 5 you will get. When you find the derivative of this. So, to find the derivative, take it in the numerator, then nx raised to n minus 1 means 6 into minus 4 into z raised to minus 4 minus 1 minus 5, then simplifying you will get the answer there. Okay, find that. I am not explaining how to find the derivative, you know it. Then f3 dash of minus 1 is minus 24 by minus 1 raised to 5 is minus 1. So, it is plus 24. Plus 24 means 4 factorial. Now, substitute the values in the given formula. Therefore, by Taylor series, 1 upon z square is equal to f of z0. F of z0 means 1, this 1 plus z minus z0. So, z minus minus 1 means z plus 1 by 1 factorial into f dash of 0. F, that is 2. 2 means 2 factorial I am writing, plus next is z plus 1 the whole square divided by 2 factorial by 2 factorial, and here it is f2 dash. f2 dash means 3 factorial it is. So, it is 3 factorial plus z plus 1 the whole cube by 3 factorial, and f3 dash. f3 dash is 4 factorial. 4 factorial plus etc. So, now to get the answer, just write the general form. So, 1 plus here in the numerator 2, here 1, here 3, here 2. So, numerator is of the form n plus 1 factorial upon n factorial into z plus 1 raised to, here it is 2, here 2, here 3, here also 3. So, n form. Then summation n equal to 1 to infinity. These two ways you can solve this question.